let us see problems. For linear interpolation, in case of equispaced tabular data, show that the error does not exist. The error does not exceed 1/8 of the second difference. 1/8 of the second difference. Solution. Now already we have seen the linear interpolation. What is the linear interpolation? F of x equal to f of x naught plus x minus x naught into f dash x naught. In linear interpolation, the error is given by E1. Do you remember? E1 f of x equal to 1/2 x minus x naught x minus x1 f double dash xi, right? Where xi belongs to what? Xi belongs to x naught comma x1. This is error. Okay, already we know this 1/2 factorial. Okay, therefore what is mod? If I consider absolute value, fx equal to mod fx equal to 1/2 mod x minus x naught x minus x1, right? And this is mod f double dash xi, and for let me write here, for equispaced data, what is x1 equal to x naught plus h? That implies x1 minus x naught equal to h, right? And what is f double dash xi? F double dash second derivative, f double dash of x naught is nothing but what? Delta square f naught by factorial 2 into h square, right? Therefore what we have here, this is modulus of E fx equal to 1/2. This is maximum over x minus x naught x minus x1, and what is this? Modulus of delta square f naught by 2h square. Okay, and the maximum, this is maximum over what? X naught less than or equal to x less than or equal to x1, and the maximum value of x minus x naught x minus x1 exist at midpoint, at x equal to x naught plus x1 by 2. Already we have seen this in one problem. Therefore what is the maximum of x minus x naught x minus x1? This is equal to x minus x naught, right? X minus x naught and x minus let me write directly. What is this? This is x means what? X naught plus x1 by 2 minus x naught, x naught plus x1 by 2 minus x1, x1 by 2 minus x1. So this is x naught minus 2 x naught. So x naught x1 minus x naught by 2 this, and this is 2x1. So this is x naught minus x1 by 2, x1 by 2. So this value is x naught minus x is h by 2, and this is minus h by 2. So totally h square by minus h square by 4. Therefore what is modulus becomes error is equal to 1/2 is already there, and what is this? Modulus is there. So modulus of minus h square. Okay, here already mod is there, so totally you will get mod. So this is h square by 4 directly plus h square by 4, and what is this is delta square f naught by 2h square, delta square h naught by 2h square. So what is this becomes completely already by 2 is included here now. This is, there is no 2 here, delta square f naught by h square. So this value is h square gets cancelled, 1 by 8 of delta square f naught, that is equal to 1 by 8 of what? Second difference. This is one problem. Okay, now take another problem. For the following data, calculate the differences and obtain the forward and backward difference polynomial. Forward and backward difference polynomials. Interpolate at x equal to 0.25 and x equal to 0.35. Solution. Okay, first data. What is the data here? X versus f of x. 0.1, 0.2, 0.3, 0.4, 0.5, and corresponding function values 1.40, 1.56, 1.76, 2.28. So solution. Here the values of x are equally spaced, right? Equally spaced with the common difference. H equal to how much? 0.1, 0.2, 0.3, 0. What is the common difference? H equal to 0.1. Okay, H equal to 0.1. And the forward difference table or the difference table, one can write the difference table for the data is the next page. This is x and this is f of x. X values are 0.1, 0.2, 0.3, 0.4, 0.5. okay, and f of x values 1.40, 1.56, 1.76, 2 and 2.28. Now first difference, one can write delta or forward table or backward table, one can use the same notations here. The first differences, what is this? This is this minus this, 1.56 minus 1.40, you know already, I told you this is this one. 1.76 minus 1.56, so this is 0.20, right in between these two values. Same, 2 minus 1.76, 0.24, 2.28 minus 2, 0.28. These are the first differences. And second differences, delta square. What is the difference? Right, difference between 0.20 and 0.16, 0.20 and 0.16, 0.04, 0.24 minus 0.20, this is also 0.04, and between these two is also 0.04, right? And the third differences, 0.04 minus 0.04, 0, and the fourth is also what? 0. Therefore, now what is the thing here? Let to get first. Now here, to get forward interpolating polynomial, assume x naught equal to 0.1, then f naught equal to 1.40, delta f naught, delta square f naught. These values are in the difference table. Okay, starting with f naught delta, and delta cube f naught delta power 4 f naught values are zeros. Now what is the formula of forward interpolation? P of x equal to f naught plus u into delta f naught, u into u minus 1 by factorial to delta square f naught, and something in delta cube f naught. What is u value here in forward interpolation? X minus x naught by h. X naught value and h value I am substituted here. Therefore substitute all these values in equation 1. So what is the polynomial? P of x is equal to, substituting all these values, and delta cube delta power values are zeros. Therefore up to second derivative, up to second forward differences, the values we have written here, and after simplifying I am getting this forward interpolating polynomial. Now the backward interpolation polynomial is now Newton's backward interpolating polynomial. Okay, here to get this, to get backward interpolating polynomial, we start with the end point. Let xn, what is xn here? X naught, x1, x2, x3, x4 value. What is this value? 0.5. Then what is fn? Fn is nothing but what? f4. What is this value? 2.28. Next del fn. Del fn is nothing but del f4. What is this value? 0.28. Next I will write here del square fn. Del square fn means del square f4 value 0.04. Similarly del cube fn, del power 4 fn values are zeros, and therefore backward interpolation formula, backward interpolation formula is, what is the formula? P of x equal to fn, okay, plus u into del fn plus u into u plus 1 by factorial to del square fn plus u into u plus 1 u plus 2 whole by factorial 3 del cube fn, and so on. This is equation 2, where what is u here? This is x minus xn by h. So x minus, what is xn endpoint? 0.5. 0.5 by h value is what? 0.1. okay, therefore what this becomes, therefore what is P of x is now fn is what? 2.28 plus u into x minus 0.5 by 0.1 multiplied by what? Del fn. What is del fn? 0.28 plus u, this is u, into u plus 1. U plus 1 becomes what? U plus 1. X minus 0.5, okay, u plus 1. What this becomes? Yeah, x minus 0.5, and this is not this one, x minus 0.4 you will get, x minus 0.4, and this is delta square. What is delta square? 0.04 by factorial 2, and remaining all terms are zeros. After simplifying, we are getting the polynomial as 2x square plus x plus 1.28, the same polynomial as forward interpolation. So interpolating polynomial is always unique. Now to get the values of what is that? To get the values of f of x or p of x at what? X equal to 0.25, 0.35, we can directly substitute x equal to 0.25, 0.35 in interpolating polynomials, in interpolating polynomial. Okay, what is that interpolating polynomial? P of x equal to 2x square plus x plus 1.28. therefore P of 0.25 equal to something, you calculate this, P of 0.35 something, right? Okay, you calculate this. Now the main point is now here, how to find how to find f of x at x equal to 0.25 and 0.35 without finding interpolating polynomial, okay. For this, okay, now the answer is when x equal to 0.25, now see 0.25 is nearer to which value? X equal to 0.25 is nearer to which value? 0.2, nearer to 0.2. Therefore take x not equal to 0.2. Then when x naught is 0.2, what is f naught becomes 1.56. What is del f naught becomes 0.20. What is del square f naught becomes 0.04, and del cube f naught becomes 0. Let us see these values again. Let me draw the table. X versus f, del and del square. What is the x value? 0.1, 0.2, 0.3, 0.4, 0.5, and function values 1.4, 1.56, 1.76 to 2.28. What are the first differences in between these two? The differences between f values 0.16 and 0.20, and this is 0.24 and this is 0.28. Next, del square value, this is 0.04, 0.04, 0.04, 0.04, and del cube, this is 0, this is 0, and del power 4, 0, right? And see, what is my x naught? Since 0.25 is nearer to what? 0.2, and this is my f naught. When this is my f naught, this is the line, slope line. This is delta f naught, this is delta square f naught, and this is delta cube f naught. So I'm writing values here. Therefore forward interpolating polynomial is what is the formula? P of x equal to f naught plus u into delta f naught, u into u minus 1 by factorial to delta square f naught. Delta cube is already 0, therefore no need to write here. And what is u? Equal to x minus x naught by h. And what is h here? H equal to 0.1. and what is x naught value? We have considered 0.2, right? Now what is the required value? 0.25 at x equal to 0.25. At x equal to 0.25, what is u becomes 0.25. Now here you, without finding polynomial, so substitute x value here, it directly it's here 0.25 minus 0.2 by 0.1, 0.25 minus 0.2 by 0.1. What is this becomes? This is 0.05 by 0.1, 0.05 by 0.1. This is 0.5 is the u value, okay. Therefore what is p of x becomes? This formula, this becomes star implies p of x equal to f naught. What is f naught? 1.56, right? Plus u into, u means 0.5, delta f naught. What is delta f naught? 0.20 plus u into u minus 1 minus 0.5 by 2, delta square f naught is what? 0.04. This is the value of what? P of 0.25. X value is what? 0.25 is equal to, if I simplify this one, I will get 1.655. Now let us see backward. What is that? Another one at x equal to what? 0.35. At x equal to 0.35. 0.35 is nearer to 0.35 is nearer to, let me consider backward formula 0.4. So this is my 0.4. So this is my xn. So this is fn, right? This is f1 means from this point onwards you draw a line here. This is del fn and this is del square fn. and this is del cube Fn, right? Then take xn equal to 0.4. Okay, then what is Fn equal to 2? Del Fn equal to what? Del Fn equal to 0.24. Del square Fn is what? 0.04. And del cube Fn is what? 0. Okay, now therefore backward interpolation formula is backward interpolation formula is p of x equal to, what is that? Fn backward Fn plus u into del Fn plus u into u plus 1 by factorial 2 into del square Fn. Del square Fn, this is the formula. What is u here? X minus xn by h. X minus xn by h. Therefore at x equal to, what is x value here? 0.35. U is equal to what? 0.35. X minus xn, what is xn? 0.4 by 0.1. So this is minus 0.05 by 0.1. So this is minus 0.5. Minus 0.5. Therefore what is p of 0.35 is equal to, p of 0.35 equal to Fn, that is 2, plus u into minus 0.5 u plus 1, sorry, u into del f naught, this is 0.24, plus u into u plus 1, u plus 1 means 0.5 by 2, del square Fn means 0.04, and substitute to simplify all these, you will get 1.875. This is backward. So this is the technique. Without finding the interpolating polynomial, one can find the values, function values, and use of forward and backward. When we have to use forward, when the required value is at the beginning of the data, then apply forward interpolation. For example, here 0.25. 0.25 is somewhere beginning. Okay, similarly 0.35 is nearer to end of the data, or 4.5 if I required 4.5 nearer to end of the data. According to the point 0.25, I have considered x0 as 0.2, and according to the point 0.35, if I want to apply backward formula, I am considering xn as 0.4. Okay, that's it, a simple idea. Now see this problem. Determine the step size h, that can be used in the tabulation of a function, f of x, where x lies between a and b at equally spaced nodal points, so that the truncation error of the quadratic interpolation. Now what is this? Of the quadratic interpolation is less than epsilon. Solution. First, let us consider quadratic interpolation means we need how many points? 3 points. To get second degree polynomial, we required 3 points. So let me decide first 3 points. Let xi minus 1, xi plus 1 denote 3 consecutive equispaced points with step size h. with step size h. That is meaning of what? Xi minus xi minus 1 is h, or you can write like this, and xi plus 1 minus xi equal to h. The differences are same. The difference between two consecutive points is same. Therefore, in quadratic interpolation, already we have seen this. In quadratic interpolation, the truncation error is what is the truncation error in quadratic interpolation? In truncation error is quadratic, particularly what is we have seen in Lagrange's, right? Do you remember? In Lagrange's quadratic interpolation, the truncation error is in quadratic interpolation. The truncation error is, what is that? E2. We have the notation E2 is less than or equal to what? Maximum of 1 by 3 factorial, maximum of a less than or equal to x less than or equal to b. Okay, or one can write, write like this: mod x minus how many 3x minus x naught, x minus x1, x minus x2, like that. Now what are the 3 points here? X minus xi minus 1, x minus xi, x minus xi plus 1 into m3. And what is m3 here? M3 is nothing but what? Maximum of third derivative, f triple dash x, right? You remember this over the interval AB. And what are the here? A and B are nothing but xi minus 1 to xi plus 1. Okay, now to get the maximum value of this function, if 2 points are there, linear interpolation, we consider midpoint. Now there are 3 points. I have to take the product of this one. You will get cubic equation and take first derivative. Instead of that, let me simplify that. To simplify the calculations, let us introduce one variable t equal to x minus xi by h. Then see what this becomes. X minus xi minus 1 means what? X minus xi minus 1 means what? X minus xi minus 1 means xi is what? Xi equal to xi minus 1 plus h. Okay, right? So xi minus 1 is what? Xi minus h. So what is this? Is x minus xi plus h, right? And what is x minus xi from this? One can write x minus xi is nothing but th. So this is th plus h. So this is what? T plus 1 into h. Same logic. Another one, x minus xi plus 1. X minus, what is xi plus 1 can be written as xi plus h, since equispaced data. So this is xi, x minus xi minus h. X minus xi is what? th. So this is what? T minus 1 into h. Therefore, what is this terms? X minus xi minus 1, x minus xi, and x minus xi plus 1 is equal to how much? X minus xi minus 1 is what? T plus 1 into h. Next one is what? X minus xi is what? th. Next one is what? T minus 1 h. So totally h cube into t square minus 1. Okay, and let this function be function of t, g of t. Therefore we have to find maximum of what? G of t function. Now you know maximum for maxima and minima, the necessary conditions for maxima are, what is the first derivative must be equals to 0, g dash t equals to 0. So what is this becomes? 3t square minus 1 equals to 0. So what are the values of t? T equal to plus or minus 1 by root 3. Now therefore what is the maximum of x minus xi minus 1, x minus xi, x minus xi plus 1. Okay, this is equal to, what is the function, the product of these three functions, maximum of g of t, isn't it? Maximum of g of t, that is equal to maximum of, what is the function, h cube is outside, h cube, maximum of what, t into t square minus 1, t into t square minus 1. So at both the points, t equal to plus or minus 1 by root 3, we have what is this, h cube into, what is, since this is modulus is there, both the points we have what, one can write t equal to, this is 1 by root 3, modulus is there, therefore 1 by 3 minus 1, 1 by 3 minus 1. So this is 2 h cube by 3 root 3. For both the points we are getting this value, right? Therefore the truncation error, in quadratic polynomial, is bounded by what, e2 of fx less than or equal to, what is that, first thing, 1 by 6 is there and m3 is there, and the maximum of this is what, 2h cube by 3 root 3, right? Okay, so this implies, what is the final answer, this one can write this equal to, what is this value, h cube by 9 root 3 into m3. Therefore finally, now we choose h, value. Okay, this is less than or equal to, remember this is less than or equal to, and these two are equal automatically, no problem. Choose h such that h cube by 9 root 3 m3 less than epsilon. That implies, what is, h is less than 9 root 3 epsilon by m3, this whole power 1 by 3. From this write h value, this is h bound. Choose h such that, what is the given error, given is less than epsilon is given, so I'm making this h value, this term value, maximum error, truncation error less than epsilon. From this get h value, this is the bound.